So everything we do with minimal water possible. We have a bag with water, and this is what we use to freshen up. As you can see, not very luxurious, but still, it's enough space for us to do what we need to do. So water is also very dangerous on the space station because we have a lot of electricity, so we need to be very careful not to spill it. So water is also very dangerous on the space. So water is also very dangerous on the space. So we just put a little bit in our washcloth, as you can see here. And with gravity, of course, and with gravity, of course, and with gravity, of course, you can form nice bubbles and they can float away. So water is also very dangerous on the space. So water is also very dangerous on the space. So we need to be very careful not to spill it.
World, if you think about it, right? It's getting nice and wet. I want to make sure for the experiment that it's really soaking wet.
So water is also very dangerous on the space station because we have a lot of electricity.
World, if you think about it, right? Okay.
So we need to be very careful not to spill it.
So I have a soaking wet washcloth here floating in front of me. Oh, there's one ball of water floating around.
So water is also very dangerous on the space
World, if you think about it, right? I'll put it on the washcloth. Okay.
So we need to be very careful not to spill it.
So here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out.
So water is also very dangerous on the space
World, if you think about it, right? It's really wet. It's becoming a tube of water. It's becoming a tube of water. It looks very cool. The water's running up my hands a little bit. Hey, Tom, can you come grab me a towel, please? I got one on the wall. It's over here by Sivas. So it'd be on the other side of Sivas there, stuck on the wall. So the water's all over my hands. In fact, it wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. The surface tension of the water keeps it stuck to my hand. Thanks, Tom. Grab the microphone. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet.
So water is also very dangerous on the space.
Thanks, Chris. Ali has a question for you.
Hi, Chris. My name's Ali. I'm in grade 9, and my question is, how long does it take to orbit Earth?
Ali, it depends how far away you are. If you think about the Earth orbiting the Sun, it takes us 365 and a quarter days. 364 and a quarter days? Anyway, 1 year. plus a leap year every 4. And so that's because we're, whatever, 93 million miles from the sun. The moon takes 1 month to go around the world because it's 400,000 kilometers away. But sort of like a ball on a string, on a long, long string, you can spin it fairly slowly and the ball will stay up. But if it's a little short string, you have to spin it really fast or the ball will fall down. Sort of the same idea in orbit. Because the moon's a long ways away, it goes around the world about once a month. And our exact altitude here, about 400 kilometers, means we have to orbit the world every 92 minutes. If we were a little further away, we'd go around the world more slowly. If we were closer, we'd have to go around faster. And one last thing, there's one orbit in between the moon that takes a month and the space station, which takes an hour and a half. There is an orbit where it takes exactly 24 hours to go around the world, if you think about it, right? 1 month, 90 minutes. There's some orbit, some distance, exactly 24 hours. So if you can orbit at exactly 24 hours around, that means you'll stay above the same place on the Earth because the Earth takes 24 hours to turn around. It's a really valuable orbit for a satellite because you can bounce your signal off it all day. And that's how I'm talking to you, in fact, off one of those satellites.